Hello. Well, it's nearly 2 weeks since I last uploaded a video, and you've probably more or less forgotten what we're up to. I've almost forgotten myself. But you'll recall that after we had a somewhat unsuccessful test in the sea, we made various changes, including to the PID parameters of the rudder control and various other things. And then we went to Bray Lake to test it in a safe environment, and it didn't work at all because I had wired up the main electronics board back to front by misplugging various plugs. So we went back again after I'd fixed that problem and colour-coded the plugs. And I'm going to tell you what happened at that trip. I'll get this on here.
We're on the right mission, and we got
telemetry. We're on mission 6.
We checked the telemetry, have we?
The telemetry's working. You can go in a circle if you like. So now we've got no wind.
I can't do anything about that.
So we've reached base safe water and we're going to Alpha, but the sun is in our eyes, so I'm going to move the camera. The incredible fact is that I cannot see a sodding... Oh, there, is that it? This boat is 110% invisible. Must be in the field there somewhere. Or at least I've found Woodstock now. He's tacking from Alpha to Bravo, and he's just turning. So Woodstock has just got into Bravo and is now running downwind to Charlie.
So is Snoopy 12.
Is it? Says you already got
because he has a much larger waypoint marker.
Yeah, oh, well that's cheating.
Compared with our 5 metres.
Yes. Yes, I can see Snoopy 12 zipping past.
Yes, it was literally just as our boat turned, within 20 seconds, 30 seconds, his boat turned, but it was a long way from our mark.
Yes.
You'll have to make the waypoint markers bigger.
Well, it was Robin who insisted I made them smaller.
Right.
So this is a test of downwind, almost directly downwind, isn't it? So, so long as it's not snaking. Well, so far the change to the PID parameters hasn't had any catastrophic effect. Well, the trip round the lake went okay, like this. Tacking from Alpha to Bravo because of the north-westerly wind. Then direct to Charlie, direct to Delta with a slight curve, and then tacking from Delta back towards base. Well, it got back to base. So the green track is when it's sailing directly, and the yellow is when it's tacking. But we did notice some anomalies in the tacking. So if I go back to here, the 2 green lines here indicate the corridor within which the boat is supposed to be tacking. And it tacks successfully down to that bottom green line and then up to the other one, changes onto the other beat. That's absolutely fine. That's fine too. But then it's supposed to be going back now up to here, but in fact it doesn't do that. It gets to about here, and the green dot there indicates that it thinks, because of a shift in the wind, it thinks it can sail directly to Bravo, and so it stops tacking, and then when the wind shifts again it resumes tacking, but in the opposite direction, and then eventually it goes so far to the west of Bravo that it can actually get back there. So this half-width tack is caused by the wind shifting, making the boat think that it can abandon tacking and sail directly. This is despite the fact that the wind vane is smoothed. The signal from the wind vane goes through an exponential filter with a 10-second time constant. And the idea of that was to prevent this kind of thing, but it didn't quite work. Similarly, when it's tacking from delta towards base, it goes over the right-hand green line, okay, turns around, goes on the opposite beat, and at this point it thinks it can sail directly. So it abandons tacking, then very quickly resumes tacking, but not on the right beat. It was supposed to be going down here, and it goes back up there. So that's just a problem that we've got to deal with. There are two possible things we could do. One is to lock the direction of tacking, so that if it temporarily abandons tacking in order to sail directly to the next waypoint, and then it decides it has to resume tacking, then it resumes in the same direction it was doing before, rather than recomputing the direction. And the other possibility is to smooth the wind vane more, or introduce some kind of counter so that we don't trust a transient shift in the wind so readily. But anyway, basically that was okay the first trip.
Right, okay then, Robin. Till the next time.
We wanted to test our new generic mission, which automatically establishes a waypoint some way upwind of where the boat is when we start. But as the wind was northwesterly, that waypoint would have been on land. So we sailed the boat out into the middle of the lake and tried to do it there. But unfortunately, it didn't work because of a bug in my wonderful software.
What effect would that have if I put that in front of...
Well, you can get polarising filters, yes. I can't really tell because all I can see is a reflection.
Well, that was the end of the second trip, and we're going to take the keel apart, have a look and see how much corrosion there is now.
The aluminium stuff inside looks okay.
Even after getting salt water on it, it looks pretty good to me. There's just a very vague sign of corrosion, but basically not corroded at all, is it?
No, a bit of oxidisation, isn't it? That is really.
See, I expected there to be corrosion between the aluminium and whatever those bolts are. I don't know whether they're stainless steel or whatever. The only thing that's rusted is that little shackle, those little shackles.
Unless that's electrolytic action happening around those.
Yes, well, I would think it is, don't you?
And tracking up the... Yeah, could well be.
Something like that. But not at all bad, considering how long it's been on there.
No.
And we had seawater at Western.
Yes.
So the only thing that's corroded is the safety wire.
Yeah.
So you want to put it back in the... let it go round the course again and time it or something?
Yeah, just see what that does, unfortunately.
Right, so this is launching it with half the keel removed. Well, the plastic membrane on one side of the keel removed. So that makes it less sort of hydrodynamic, but thinner and with no water in it.
I'm confident enough in it getting on with it to go and have a cup of tea, don't you think?
I could certainly do with a cup of tea. It was getting bitterly cold, so we repaired to the cafe and had a tea and cake, and the boat went round by itself and came back, and we packed up and went home. But of course we could see
what it had done whilst we were having our tea from the telemetry replay, and everything was fine until it eventually got becalmed up here, and we had to use a little radio control to ease it towards the shore, and then Dick picked it up, and that was the end. One of the problems I have now with this new deep keel is that I cannot actually erect the mast in my hall because the ceiling is a couple of inches too low. So testing it, I have to put it horizontal like this, which is a bit awkward. During the test, we'd noticed some very high wind speeds reported on the telemetry, about up to 130 mph, which was obviously ridiculous. So when I got home, I tested the wind vane by itself on a breadboard, and it became apparent that the basic problem was too much contact bounce in the reed switch that senses the movement of the cup anemometer. The scope shows the raw signal from the reed switch in yellow and a debounce signal in cyan. And at first sight it looks all right, but if you look at it more closely, you can see that there is a significant amount of bounce. Sometimes the debounce circuit managed to cope with it, and sometimes it does not, as shown here. I've improved the debounce circuit since then, but there's a fundamental problem that the longer the time constant in the debouncer is, then the slower the maximum wind speed that you can actually measure becomes. Whether a Hall effect sensor would be less prone to bounce, I do not know, but we'll obviously have to work on that. Well, I think I can safely claim that this is the biggest and most unsatisfactory bird's nest that I have so far created. We started off with this ferro board here, and then I added that one to drive the leads, and now I've added this one to debounce the anemometer data properly, and we've got connectors all over this ferro board in a totally random order, which I have colour coded now, at least so that I may have some chance of getting them back when every time I take this thing out. Whether it still works or not, I know not. We had a little snow, which was unusual for Hampshire, but not enough to be interesting, at least not enough to be interesting to a man who used to be secretary of the All-Wheel Drive Club. So that was quite a successful test. The tacking worked apart from the anomaly I mentioned, and everything else worked, the telemetry and so on. And it seemed that the change to the PID parameters had not caused any disastrous malfunction, although we weren't really able to test the effect of increasing the D, the derivative factor in PID, because we weren't in the sea and there wasn't enough strong enough wind to test it out properly. So probably we'll go back to Western on Southampton Water as soon as we can and run a test there. Meanwhile, I've been working on a completely different aspect of this project, which will be in the next video. And Dick has been packing up a farm owned by a relative of his who sadly died. So we haven't been doing much in the last couple of weeks. Anyway, thanks very much for watching.